Hey everybody, it's Mr. Roy. Let's work with Excel on our range equation labs. This is just a tutorial to help you with your graphing and using Excel as a good tool for managing your data. Here's the data I collected from my trials. I have my muzzle velocity, I've got 3 of them, and I've also got all of my trials of my launch for my darts for my different angles. So this is what was on the sheet. I'm going to have to fill this out. First thing, let's do our muzzle velocity. I could do the average on my calculator. Much more effective though is to actually use the function in here. So I'm going to click that f of x. I'm going to say average is good. That's what I want to do. So I'll go OK for the average, and then I'm going to grab these 3 different trials for the muzzle velocity, and I'll say OK, and it's going to do that for me and put in my average. Any minute it'll do it. All right, it's having a little trouble. Let's try that again. There we go. Okay, got my average of 19.64. You might say, well, it's rounded to two decimal places. How did it know to do that? If you right click on a cell and you go into Format Cells, you'll see this pop up, and I can click, it'll default to general, but I can pick number, and then I can pick a number of decimal places. This doesn't mean that it's actually rounded the number. This just means that it's showing a rounded value, but hidden in that cell is the actual unrounded value. So I've asked it to show to 2 decimal places, but it's actually a lot more than that, right? And if I were to go to Format Cell, and I were to go just change it to general, you'll see I get an unrounded, like a much longer number. And in fact, the number keeps going after that, but that's what it's got room for. I like though to round it, so I'm going to say number of significant digits. Each of these ones in the average is 4, so I'm going to try and keep it the same and consistent in my answer there, just for what it looks like. Okay, so now we'll say, let's input our other data here. First of all, we've got our predicted range. This one can get like a little bit tricky. You could just do the calculation and then put the number into your Excel spreadsheet, and that's fine. I'm going to show you how to use Excel to build an equation to do this for you, though, and it's actually a little more tricky than you might think because Excel assumes you're working in radians, which is not actually the case. So I'm going to hit the equal sign to tell it that I'm going to do an equation. And the first thing I need to do is I need to take my muzzle velocity and I need to square it, my initial velocity. So I'm going to like pick this one here, and I'm going to put that little caret and a 2. That means it's going to take that number, what's in that cell, and it's going to square it for me. But that's not enough. That's not my whole equation. So I'm going to keep going. You'll see I'm up in the top bar here now. I actually need to take that value and multiply it by sine 2 theta. But I'm going to put some brackets on here just to make sure nothing gets messed up. And so I'll go times sine, and then in the sine, I'm going to say I want to do the sine of um, 2 times the angle, sine of 2 theta. Okay, now there's one more little problem here, and that problem is that it thinks I'm working in radians right now. So I have to tell it that I'm working in, I have to tell it that, that's not, that's not actually the case. So here's how I'm going to deal with that. I have the 30 here, that's in degrees. I'm going to actually need to convert that into radians before it goes into my equation. So I'm actually going to write radians, and then I'm going to put brackets around this to say, okay, what it's going to do is it's going to take my 30 degrees, it's going to double it, it's going to turn all of that into radians, and then it's going to do the sine calculation with radians because it defaults to using radians. Okay, that's a bit of a pain, but that's okay. And now I need to divide by 9.8 because that's part of my equation. Now I want to make sure that that 9.8 isn't just dividing the last part here. So I'm going to throw some more brackets around here just to make sure that 9.8 is dividing everything on the numerator, make sure everything is behaving as it should. Here we go. I got 34.08. Now here's the nice thing. I can take this and just drag this down. There is going to be one little problem though, right? My next cell here is actually not using the average velocity in this cell here. It's trying to get the one below it, but there isn't one below it. So I need to change this D4 into a D3, but I notice that my angle is A7, so it actually is using the proper angle. It's using 40 degrees for this one. So I'll hit enter there. For this one, I'm going to do the same. I'm going to enter D3. For the next one, I'm going to enter D3. And for the last one, I'm going to enter D3. Okay, so that's done the calculation for me. That's my predicted range, and I've taken care of the rounding off just to make it look a little neater and tidier. Okay, now let's have a look at those are our predicted values. Let's have a look at our actual values here. I want to do the average for those. So again, I'll go in here, I'll click my function, I'll say an average, yes please. What cells? These three right here. And it seems to be a little nitpicky about average. It's having a little bit of trouble here. Let's see if we can get it to cooperate with us. Okay, there we go. I'm going to drag this down. So I just grab this little green box in the corner and drag it down. That's the beauty of using Excel is you can copy the formula into a whole bunch of cells and it'll keep picking up the correct data from the next iteration. Okay, now let's do my percent error. I can do that one in Excel as well. I have to write the equation for this though. So I'm going to go equals, and then we're going to take our predicted value. We'll subtract our actual value, and we'll divide that by our predicted value. And then I got to multiply all of that by 100. So just to make sure I'm not multiplying the denominator by 100, I'm going to throw brackets around that as well. So we'll put some brackets around there, and then we'll go divide by 9.8. So this is what it would look like. And I'll go enter, and it's going to give me my percent error. Now that doesn't look right, so it must mean I made a little mistake in my formula. Oh yeah, I got an F. No, that should be right. Oh, it's not divided by 9.8, it's times 100. I was doing the range equation again, but this is percent error. So I got to multiply that by 100. Okay, there we go, 56%. Drag that down. Okay, so here's my percent error. I'm like, you know, in somewhere in like the 50s for most of these, which is like pretty normal for Nerf guns. They don't, like if you were to shoot a ball bearing, it's not affected by air resistance hardly at all. So we would expect that to be a low number, like, you know, 1 or 2%, maybe like 4%. These ones are huge because these are foam darts, right? They're really affected by air resistance and wind and all those other things. Okay, so I've got those. Now it's time to make my graphs. So here we go. The first one, I'm going to grab my data. I need my angle and my predicted range. So I'll hit insert, which you can't see, it's just outside of your screen. And then I'm going to hit my chart here and I'll make a scatter plot. And here's my scatter plot. I'm going to add some stuff to it, some axis titles. Why don't I title those first? The first chart, I'll actually go through all the titling, and then the second one you can kind of assume from there. So I can say Nerf dart uh, um, launch angle versus range. And then I'm going to go, this is my theoretical. And now on the bottom here, I have my degrees. So I'm going to say launch angle, and my units are degrees above horizontal. And then for my other one here, this is my dependent variable. I'm going to say it is horizontal range, and that's in meters. Okay, so there's my thing. Now I want to put on my trend lines, right? So again, on the plus, I'm going to go trend line, but I don't want it to just assume linear. So I got to click here and go more options. Let's choose my more. Now, if it shows you this, you'll pick the little chart here. It probably will default just to the chart, but if it doesn't, pick the little chart there. Okay, so let's scroll down. I know I want to turn on my equation and my R squared value. Okay, and currently it's a straight line. This doesn't look linear to me. We assume it is a polynomial order 2 because we know it is a quadratic relationship. So that's just the one we're going to go for. My R squared value, you'll notice, is 1, meaning this is a perfect relationship. If you did the calculations on your calculator and inputted rounded values into your spreadsheet, it's probably not going to be 1. It'll be like 0.9962 or something, really close to 1. Because I kept my values in this spreadsheet, the spreadsheet actually knows all the decimal numbers. It's just not displaying them all, but it knows them. And so that's why it's a perfect relationship here. I actually want to make this a little bigger, so I'm going to make this bold, which is going to look nice, and I'm going to make it a little bigger like that. And I'm going to move it over here so we can see it. Okay, our R squared value is 1, meaning this is a perfect quadratic. It fits a quadratic relationship perfectly. And there's my equation, which is, the kind of thing we see in math class, this quadratic relationship that models this mathematically. Okay, so there's my my first graph done. Nice. My second one, I'm not going to go through all the details, but I am going to show you how to start graphing it, because you're going to need to grab your angle in degrees. Then you're going to need to hit down the control button on your keyboard if you're using a PC. I'm not sure what that would be for a Mac, but Mac users, I hope you know what you would normally push for control. Because I can't grab them all at once, I actually want this data over here. So I'll grab degrees, I'll hold down control, and then I'll grab my average range here. And now I've got my X and my Y values for my next graph. I'll hit insert, and I'll go to my scatter plot. Here it is. You'll notice that's not that same beautiful shape as my last one. Let's put in our stuff for this one. So we'll go, okay, we'll turn on our axes. I'm not going to label them. That's something you can do on your own. For the trend line, I'm going to go again to more options, click on the graph here. We'll go display equation and R squared value and polynomial order 2. And you look at this, oh man, my R squared value is 0.6062, way lower than 1. That's telling me my data does not is not modeled well with a quadratic relationship at all. Of course, I can bold that one, make it bigger, all that good stuff. You've already seen me do that, so I'm not going to mention that. But what I will mention is, look at all this empty space at the bottom of the graph. I can get rid of that so I can have a cleaner look at my data here. Sometimes you do want to go start at 0 so you can see the full trend. In this case, it's not really super helpful to do that. So this one, I'm going to not do that. I'm going to do my to go to my axis options here. And instead of a minimum of a 0 in the y-axis, I think I want to go to like 10. Let's try 10 and see how that looks. Oh, that's better. I could probably go all the way to 12. There we go. That looks really nice, much easier to see the stuff on my graph. So there is my second graph. I need to obviously label it and organize it and clean it up a little bit, but now I'm able to compare them. I'm able to compare the R squared values, knowing that an R squared value closer to 1 means a relationship that is more perfectly modeled by a quadratic in this case, or a line if we're doing linear relationships. So our theoretical one is a perfect quadratic. Our other one here is far from a perfect quadratic, really big difference between the two. Then of course I can look back at my percent error for different things and all that kind of stuff and write up my lab report. But this is how you will do your graphs, and now you can analyze them from here. Good luck in your lab report. I hope it goes well. Come and see me if you've got questions or need a little support on this. Good luck.